So a dilation is when you grow a figure or you shrink a figure and all of the points increase or decrease by the same factor. And we call that the scale factor. Um, for people who do like architecture and stuff, they build scale models. For people that build like ships in a bottle and stuff, those are miniature representations of much larger objects. So that is what we consider to be a dilation. If you look at this video right now, we have a triangle that is about, it has a scale of 1 and it's going to increase up to a maximum of a scale of 2 and decrease to about half that size. So you can see it growing to a scale factor of 2, shrinking all the way down to half, and then back up to 2. So now this animation I did in Desmos, and it's something that I want us to be able to use in class so we can learn how to draw some stuff. So now when we dilate, we typically dilate about the origin. And so that's what we're going to do in the next slide. So when we dilate about the origin, we count the distance each point is from the origin, and we multiply that distance by 2.5. So we're moving horizontally and we're moving vertically. So now if we look at point A has a coordinate of 2, 1. So it is this point. So now if we count back to the origin, we move 1 and we move 2 and we move down 1. So probably have to make this larger. So for A, its first coordinate is 2, so we need to multiply 2 by 2.5, and we need to multiply its y coordinate 1 also by 2.5. That gives us a new coordinate of 5, 2.5. That would be its dilated coordinate. Now we can do the same thing with B. B's coordinate is 4, 3. So B is 1, 2, 3, 4, 4 horizontally away from the origin, and 1, 2, 3 vertically away from the origin. So its new coordinate should be 4 times 2.5, comma 3 times 2.5. And that's going to equal 10, 7.5 for the B coordinate. And similarly for C, C's coordinate is going to be -4 times 2.5, comma 2 times 2.5, which equals -10, +5. So now we're going to graph this in a pretty nifty way. Duplicate this triangle. We're going to change the color to red, and we're going to edit the points. So now point A should end up at +5, 2.5. So you know what? Actually, we're going to move C first, or B. So B should be at 10, over at 10, and up at 7.5. So like close to here. A should go to 5, 2.5, so like right here, close enough. And then for C, C should be at -10, +5. So we can see that this red triangle is 2.5 times the size of the black triangle, and the dilation is centered at the origin. It's based on the distance from the origin. So now that's how we increase during the dilation. We're going to do something similar where we shrink down on the next slide. So now for this figure, we're dilating by a scale factor of 1/2. We're still counting towards the origin horizontally and vertically. So let's see what happens. So A's coordinate is -8, +6. So we know that it's 8 units away to the left. So when we multiply by 1/2, the 8 is going to turn to a -4, and the 6 is going to turn into a +3. The B coordinate is going to turn to a -2, and the y coordinate is going to turn to a positive 1.5. And lastly, the c coordinate is going to turn to a 4, and the y coordinate is going to turn to a 2. So when we grab this, we're going to do the same thing where we duplicate. I'm going to turn it red, and we're going to edit the points. So now instead of being at negative 8, 6, A is going to move to negative 4, positive 3, which is right here. B is going to move to negative 2, positive 1.5. And C is going to move from 8, 4 to 4, 2. So now we can see that this figure is half the size, or it decreased by a scale factor of 1/2. So now that's how we dilate figures centered at the origin. So next is, what if we want to dilate and the point is not centered at the origin? So in this figure, we're performing a dilation centered at 4, 5. So if you'll give me a moment, insert shape. So 4, 5 is right here. So I'm going to insert a little circle. Make that a little bit larger. So now 4, 5 is right here. So that's our center of dilation, this point. So now when we look at these points, we want to do the same thing. We want to count the distance from the vertex to the center of dilation. And then in this case, we're going to multiply the distance by a scale factor of 2. So now when we look at coordinate A is 1, 2 from the point of dilation to the left. So when we double that, its distance needs to be 4. So that means we're going to have to go back to the origin. So we're going to set, like, that distance is 4. So we subtract that from this 4 to get 0. So that coordinate is going to be, its x coordinate is going to be 0. And then from point A is 1, 2, 3, 4 away from this point vertically. So then its double distance should be 8. So if we count 8 away from this, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. And remember, the x coordinate was already 0. So this new coordinate is going to be 0, negative 3. For B, whose coordinate is 4, 3, B is in line with it's in line horizontally, so that coordinate won't change. Its distance is 0, so 0 times 2 is 2, so that's going to stay exactly where it is. So that coordinate is going to stay 4, but vertically its distance is 1, 2 away. So when we double that, it has to be 4. So now we count from this point 4 units. 1, 2, 3, 4. And so B's new coordinate becomes 4, 1. And lastly, for C, C is 1, 2, 3, 4, 5, 6, 7, 8 away. So now when we double that, it's going to be 16. So we count 16 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So really we could do 4 minus 16, and we end up with a coordinate of negative 12 for the x. And vertically, C is 1, 2, 3 away. So when we double that distance, we're going to get 6. And 5 minus 6 is negative 1. So we're going to end up down here. So C's new coordinate is negative 12, negative 1. Now I apologize for not having a grid large enough for this, but we kind of see what happens. So now we're going to duplicate this and watch how large this thing gets. So now A's new coordinate is 0, -3. So we're going to go down to 0, -3. We're going to go to 4, 1. And then we're going to go to -12, which is like way over here, and -1. So now we can see we've dilated this from this point. You can see that both things seem like they're coming from this point. And so that's how we do a dilation from some point other than the origin. You count the distance from the vertex to the center of dilation, you double that distance, and then you subtract it from the x coordinate and then subsequently from the y coordinate. So again, for like A's coordinate, which was 2, 1, A was 1, 2 away from the center point 4, 5. So when we double that distance of 2, we get 4, and when we subtract 4 from this 4, we got 0. Similarly for B was 1 is y coordinate for A was 1, 2, 3, 4 away vertically. So when we double that distance, we get 8. And when we subtract 8 from 5, we get -3. So that's how we perform a dilation at some point other than the origin. Lastly is, what if you're given two figures and you have to determine the scale factor? So all you have to do is pick a point from one figure and the corresponding point on the other figure to determine the scale factor. So if we look at like maybe coordinate A's coordinate is -9, +9. And B's coordinate is in A prime's coordinate. So if we look at A, it's right here. So A prime is probably, not probably, is this coordinate. And A's coordinate is -3, 3. So if we want to figure out the scale factor, give me a moment, we're going to insert a text box. So all we have to do is divide the coordinate of the dilated figure by the coordinate of the original figure, and we get the dilation. So in this case, we're going to have -3 divided by -9, and that equals 1/3. So this figure is a third of the green figure is a third of the size of the original figure. So also, if you get a negative, just make the number positive, because scale factor always has to be positive. So guys, that concludes this video. We covered line symmetry, rotational symmetry, plane symmetry, axis symmetry for 3D figures, and we did dilations about the origin, away from the origin, and we were able to determine a scale factor. So if you had trouble, please go back there and watch the video, come to class with questions, and remember, we have tests coming up Monday and Tuesday of next week. Best of luck to you guys. I'll see you in class.